What's up, Algebra 2? Here we have solving with matrices. And we're going to show you this is just another tool in the toolbox. We got the same system of equation 3 times. We're going to go substitution, elimination, and then to matrices. All right, and we're going to leave off the graphing. So for substitution, we got either one here. We could go with a nice substitution. Let's get x by itself in the bottom. So minus the 3y over. Subtract 3y from both sides. Okay, now we have what x equals, and we can substitute it into that one. So we'll have 2 times negative 3y plus 9 plus y equals 8. Distribute your 2, negative 6y plus 18 plus y equals 8. Negative 6y plus y is negative 5y. Let's subtract 18. Give you a chance to catch up there if I'm going too fast. And divide by negative 5. Y equals 2. And then we're going to bring that back up to our x equals equation. Negative 3 times y. Well, I know what y is. Y is 2. Plus 9. X equals 3. So we'll have 3, 2. All right, let's go over to elimination. Okay, again, we got some nice ones. We could choose to cancel out the x's, choose to cancel out the y's. I'm going to choose to multiply negative 2 to this row. Don't forget to take that negative 2 to the answer side. That's a common mistake. We're going to do a light squiggle through there so we know not to use that one. But we can use that one if we need to at the end. Okay, let's add down. Those should cancel. Y and negative 6y is negative 5y. 8 and negative 18 is negative 10. Divide by negative 5. Y equals 2. Plug it back in. I'm going to go to the middle one that we kind of lightly crossed out. Minus 6. And there's our 3. 3, 2. Okay, so we've done the same system, substitution and elimination. And now we're going to go matrices and hopefully get 3, 2. So we can look at this and we can turn this into kind of a matrix equation. We're going to take the coefficients, 2, 1, that's 1y, 1x and 3y. So you're just going to take the coefficients or the numbers that would be attached to those variables. 2, 1, 1, 3 times x, y in a little tiny matrix. Why do we have that? Rows times columns. 2x, 1y, 1x, 3y equals 8 and 9. Okay, now solving with multiplication, we want to get rid of whatever's touching the variables, right? If it's 3x equals 9, you would divide by 3 or multiply by 1/3. So we need to get the inverse of this matrix to multiply to both sides. So let's work on that. Okay, our determinant equals, oh, I need to move up because this is going to be tight for space. Okay, 6, 2 times 3 is 6, minus 1 times 1 is 1. Remember the determinant, difference of the diagonals? So our determinant is 5. Now to get the inverse, it's 1 over that determinant times the first diagonal flip-flop spots, and then the ones, or not necessarily the ones just because they're ones, but these spots change their sign. So they were positive, so they will be negative now. And we'll multiply that 1/5 through. There is our inverse matrix. 3/5, negative 1/5, negative 1/5, 2/5. Okay? So, again, pretending this is like 3 times x equals 9, you would multiply by 1/3 to both sides. Okay? So we are going to multiply the inverse here first. 3/5, negative 1/5, negative 1/5, 2/5 times our equation here, 2, 1, 1, 3. So we put the inverse in the front of that, and we'll show you why in just a second. And if we do it to the left side, you got to do it to the right side. And the order does matter, because if you put it behind, you won't be able to multiply because it's a 2 by 1 times a 2 by 2. It needs to be in the front, so it's a 2 by 2 times a 2 by 1. Right, so if we did, if you had 3x equals 9, you'd multiply by 1/3 to both sides, or divide by 3 on both sides. So that's why we have to do this inverse matrix to both sides. Okay, this next part, we're just going to do it this one time for notes to show you what's going on. And you won't have to do this work on the left-hand side unlike the test. You'll still have to do the work on the right-hand side, but we just need to do it one time here in notes to be aware and know what's going on and tie it all together. Okay? So we got our 2 by 2 times a 2 by 2. Okay, rows times columns. 3/5 times 2 is 6/5 minus 1/5 times 1. So we had 6/5 minus 1/5 for the top left corner. Top row, right column. 3/5 times 1, negative 1/5 times 3. So that's going to be 3/5 and negative 3/5. Okay, bottom row left column. Negative 1/5 times 2, 2/5 times 1. So it's negative 2/5 and positive 2/5. And then bottom row right column, we'll have negative 1/5, and then 2/5 times 3 is going to be 6/5. Okay, so looking at this, 3/5 minus 3/5 is going to be 0. Negative 2/5 plus 2/5 is going to be 0. Six-fifths minus 1/5 should be 5/5, which is 1. Negative 1/5 plus 6/5 is 5/5, which is 1. Okay, so we have our identity matrix, 1, 0, 0, 1. Okay, so these two multiplied to make the identity matrix times x, y. Okay, and let's just finish this side off. Identity matrix, 2 by 2 times a 2 by 1 should be a 2 by 1. 1, 0 times xy. 1x plus 0y is just going to be x. 0x, 1y is y. That's why it's the identity matrix. It keeps the identity. So when I multiply this to something else, it doesn't change. It keeps its identity. So you won't have to do this left side right here. You have to write this down, but you won't have to do this. Okay, now we know what happens. It goes to the identity matrix and that stays the same. So you won't have to do those steps. You will have to do these over here. Okay? So we got 2 by 2 times a 2 by 1. All right, so 3/5 times 8. That is 24/5. And then negative 1/5 times 9, so minus 9/5. And just a little quick mental math there, that should be 15/5. It's going to be 3. Bottom row, negative 1/5 times 8. We got negative 8/5. 2/5 times 9, positive 18/5. That's going to be 10/5, or 2. So we got 3, 2, which is also 3, 2, which is the point we had on all of them. Hooray! Again, this one's a little bit long. Okay, a lot of work, a lot of understanding, a lot of parts. All right, we're going to have to go through all this, get the inverse, write down that you're multiplying the inverse to both sides, but then you won't have to do that part. Okay, let's do another one, maybe slow motion together here, just so we are all on the same page of what we need to do. Okay, let's turn this into matrix form. Okay, we're going to copy the coefficients. 2, negative 1y. So 2, negative 1 there in the top right. 6, negative 2. Then your variable matrix, xy, equals negative 7, negative 18. Okay, so there's our setup. Now we need the determinant. So determinant is the difference of the diagonals. So we got 2 times negative 2. So that's going to be negative 4 minus, always a minus there. 6 times negative 1 times 6. So it's going to be minus a negative 6. Negative 4 minus negative, so really plus 6. So we got a determinant of 2. Okay, so what's our inverse matrix? 1 over 2 times these two flip spots. So the negative 2 goes up, positive 2 goes down. These two spots change their signs. So negative 1 is now a positive 1, positive 6 is now a negative 6. Okay, half times negative 2 is negative 1. Half times 1 is a half, sorry. You're going to have some fractions in here sometimes. Negative 3 and a 1. That's our inverse matrix. All right. So we're going to take that inverse matrix to both sides of our equation. All right, now we're just writing down the rest of it. Okay, remember the inverse needs to go in the front on the answer side. Negative 7, negative 18. Okay, a lot of writing down today. Sorry, kids, I know it's a lot of writing. but we're getting the process of it down for the 2x2s today, and then you'll get to do the 3x3s basically all on the calculator tomorrow. All right, so here's the difference from the front side to the back side and what you have to do on a test. Okay, we just need to know that these are going to cancel out. Okay, and we're going to have xy. Okay, now we actually have to do this. -1, so we got rows times columns. 2x2 with the 2x1 should just give me a 2x1. So we're going to have -7 times -1 times -7 is positive 7. Half times -18 is going to be -9. Bottom row, so we're going to have -3 times -7 for a positive 21. 1 times -18 for a -18. Xy equals -2, positive 3, and then is your coordinate point, -2, 3. All right. Now, if you need to rewind that and watch it again, let's do that. That's the best part of the video. Otherwise, let's have you push pause and give that bottom one a go on your own. All right, welcome back. Let's see how you did. Okay, we're going to change it into matrix form. We're going to calculate our determinant. -12 minus -15 is going to be a positive 3. 1 over determinant. These two flip spots. 6 goes up, -2 goes down. These two change their signs. Positive 5, -3. Take that 1/3 in there. Okay, that's your inverse. Multiply your inverse to both sides in the front of both sides. See, I forgot to do it in the front, so I had to scratch that out and put it in the back. Okay, we just need to know that these are going to cancel now. And on this side, we have 2 times -10 for -20. 5/3 times 18. 18 divided by 3 is 6, times 5 is a plus 30 for a total of 10 on the top. -1 times -10 is a positive 10. -2/3 times 18. Again, I'm going to do the divide by 3 with this part. 18 divided by 3 is 6, times -2, we got -12. And let's put our answer as a coordinate point, 10, -2. All right, folks, there you go. Some tougher stuff today, a lot of thinking, a lot of writing, a lot of attention to detail. So take it slow and don't make silly mistakes. Take it slow. And we'll be doing the 3x3s next time, primarily on the calculator. Okay, thanks for watching, everybody. Good luck.